Our 0654 Winter 21 question paper 4.1 question 6. We're looking here at moments and turning effects. Okay, anytime you see this pivot with a couple of masses on there, then you are definitely going to be looking at something to do with moments, and that's all to do with rotation. Okay, we're told that this system is in equilibrium, and the first question asks you is what that means. Well, okay, the meaning of the word equilibrium really has two things there. Okay, one is a state of zero net force. Okay, and if you can see here on the right hand side, I've highlighted the mark scheme for this question here. I've said zero net force, and they've said no resultant force. That is the same meaning, just different words. And if you wrote zero net force, then that would be fine. What you need to make sure you're writing here is something about forces, and the idea that the forces up, down, left, and right are all balanced. Okay. Now the other thing that needs to be balanced here are the moments. And again, you can see that I've written slightly different words. I've said that there's zero net moment. Now the moment is the turning effect of a force. And so therefore, if there is zero net moment, then that means there is no resultant turning effect. Okay. The reason I've sort of put up the mark scheme here is because sometimes it's a bit tricky interpreting the mark schemes. When there is an underlined part in the mark scheme, that means you must have two things. Okay, so if you just write no resultant force, unfortunately you won't get a mark here. Okay, you have to have two ideas, one of them being that there is no resultant force and that there is no turning effect, or there's no moment in the situation here. The result of that is that it will neither move nor rotate. Okay, however, we're trying to kind of explain why that is. Okay, so quite a sort of tough first mark to get there. Let's have a look at the next bit, see if we're a bit easier. Okay, we're asked to calculate the weight of the 20-gram mass. Okay, now before we look at the working, I really want to suggest to you that anytime you do a multiplication question or a calculation question in general, look at the number of marks available, because in this case it's a 3-mark question. Why 3? Well, that's the question you should be asking yourself. Where's the extra bit? Usually 2 marks, one from working, one for answer. Where's that extra mark coming from? Well, the extra mark comes from, and you can see it on the right hand side, this identification that we are working in grams. And we need to convert that to kilograms. And that's what you should always do whenever you're doing these problems. Make sure you're converting to the right units. So if you're dealing with grams, turn it into kilograms. If you're dealing with hours, turn it into seconds. If you're dealing with kilometers, turn it into meters, because those are the SI units. In this case, we're dealing with mass, and so you get a mark there for converting here. Okay, we then need to use our equation, W equal to mg. I like to try and think of ways to remember this. I like to remember as weight is made by gravity. W, weight, is made, m, by gravity, g. W equal to mg. And therefore, and we know that g is 10. Okay, it's told in the question, and therefore we've got a weight there of 0.2 newtons. Now, if you were to get this wrong, if you forget the grams, that means that your value would be too big. However, if you're marking your own papers, one thing to remember is that Cambridge tends to punish you once and once only, which means if you got that wrong, you probably would lose 1 mark. You wouldn't lose all the marks here, so don't worry about that too much. Okay. The next question is a really tough one. For 0654 physics, I think this is a really nasty question. Okay, it's a 4-mark calculation question. However, it is one which you can get marks in. Okay, you're asked to calculate the mass of the stone. Okay, let's just review what the situation is here. We've got a stone on the left, which is a distance of 0.19 away from the pivot, and we've got a mass here, which is balancing it. Well, in this case, we have to use our second part of our equilibrium condition, which is that the moments are balanced. Now the moment is the product of force times the distance from the pivot. In other words, F times D. And in the case of our two objects, one of them is going to give an anti-clockwise and the other a clockwise moment, and therefore we need to make those things balanced. So if on the left hand side, for example, we're dealing with F1, and right hand side F2, D1 and D2 respectively, then what we need to do is balance those moments. Now the forces in this case are the weights of the masses, okay, which is why my F1 has become M1 times G, force is weight, weight is mg, and F2 has become M2 times G. And you'll notice there that G can cancel. So actually, our equation becomes this, M1 times D1 equal to M2 times D2. After this, all we need to do is put in the numbers. We know that D1 on the left-hand side, 0.19, 0.25 on the right, and we can rearrange a few things, and we get an answer here of 26 grams. Okay, now, where are we getting the marks from here? We need to have an idea that we understand that the clockwise moment is calculated in a certain way. So if you calculate the clockwise moment, fantastic. Okay, if you calculate, if you then state that that anti-clockwise moment is equal to the clockwise moment, there's another mark there, and then there's another mark for getting the value, essentially. Okay, this 0.263 kilograms or 26 grams, both would work. The mark that you should always be able to get, okay, is this one down here. The idea that we need to use units. Okay, you notice here that we're asked for the units of mass. Okay, well, mass is expressed in grams or kilograms. So even if you have zero idea what's going on in this question, and I think a lot of people will, because moments is something that comes up very, very rarely in the 0654 syllabus, you can always get at least one mark, okay, by thinking about what those units are. So please don't give up. If you are thinking that you don't really know what's going on here, look for the marks that you can get. 1 mark, it may not sound like a lot, but it does make a difference in the end. All right, last bit of this question, we want to find the volume of an irregular object. Okay, well, for the irregular object, we use a method called the displacement method. Okay, what we would do is we'd fill a measuring cylinder with water, we'd measure the initial volume, place the stone in to the water, assume it drops to the bottom, and then find the volume of the stone, okay, and that is the difference between the final and initial volume. So if you like, we measure V1, we measure V2, and the volume of the stone is V1 take away V2. Now again, I think it's interesting here to compare my answer to the mark scheme. Again, if you're working independently, you'll be referring to mark schemes a lot, and there's not a lot of detail given in there. Okay, immerse in water, measure a volume of displaced water. Now the question would be, if you were to write that down in an exam, would that get you the marks? It's a very simplistic answer, might get you the marks there, but I would always just give a bit of an explanation as to what's going on. Use some good English here to try and explain your thoughts, explain how it works, and make sure you cover all the bases, because it may be that in different years they're looking for a little bit more detail. Okay, and maybe a 3-mark question instead of a 2-mark question, in which case you might be asked to explain how you do your calculations. So anytime you're doing these questions, really make sure that you're explaining as fully as possible. All right, I hope that's clear. Hope it's helpful seeing the mark scheme and the example answer. Again, as usual, if you've got any questions, let me know.